Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and going to be taking a look back almost 2 months now to Hurricane Helene, which obviously had devastating effects on the North Carolina mountains, but near the coast where it made landfall, things were not nearly as bad as anticipated. And I think the same thing can be said about Hurricane Milton. In fact, there was more damage from tornadoes that were spawned by the hurricane along the east coast of Florida than there was along the west coast where the storm actually made landfall. So obviously, when things like this happen, then the public perception is that either somebody made a mistake or they're overblowing it just for the sake of overblowing it. And I can assure you that neither of those is true, but there definitely needs to be some research about this because we've seen it happen now too many times to ignore, and there is research ongoing, and I'll touch on all of that in just a little bit. So, with all that being said, I want to start off by showing you a radar image from the Tallahassee, Florida Doppler radar at 10:56 p.m. on September 26th. Now, the reflectivity image is on the left and the velocity image is on the right. And you can see the eye having come ashore near Adams Beach. Okay, I actually drove down there about 7 o'clock that evening, and the Gulf of Mexico didn't look all that terribly rough, but obviously things changed over the next 4 hours. But over on the right, if you look real carefully there, and this is from the app Radar Scope, which is my favorite radar app, and I decided to subscribe with all the bells and whistles, which allows me to look at archived data. And so in the middle of that picture on the right, you can see the minus 136.5. What that means is that the radar in Tallahassee was detecting an inbound wind. That's what the minus sign means. An inbound wind toward the radar sustained at 136.5 miles per hour. Okay? Now, the radar beam was hitting that, was sampling the atmosphere at an elevation of 3,500 feet. Okay? Now, it is true, and we'll talk about this in a second, that surface winds are always going to be lower than the winds aloft because of the effects of friction. That land has a lot more friction than water, obviously, and so it's going to slow the wind down a little bit. But to the degree that this happened, I don't think that can explain everything. Okay, so here was the 11 o'clock advisory from the National Hurricane Center. Hurricane Helene very close to making landfall in the Florida Big Bend, accompanied by catastrophic storm surge and life-threatening winds. And they had talked in previous advisories about how these life-threatening winds were going to extend well inland, okay, which certainly would have included where I was in Perry, Florida. So, some things to keep in mind here. The radar doesn't lie, okay? Sustained winds in excess of 130 miles per hour were indeed occurring 3,500 feet above where I was. Now, the National Hurricane Center is the official government agency charged with helping citizens to protect life and property to the extent possible. They absolutely have to err on the side of the worst case scenario. And to give you an example with Milton, everybody knew that Milton was going to weaken by the time it actually made landfall along the west coast of Florida, but nobody knew exactly how much. And there's a big difference between a Category 4 and a Category 2, and so the uncertainty was there. If they forecasted to go to a Cat 2 and say, it's not going to be that bad, and then it makes landfall as a Cat 4, they're in big trouble, okay? They're in huge trouble. And so they have to err on the side of caution here to make sure that everybody is aware of the threat, even though it scares me that I hear more and more people saying, they always overdo it, I'm just going to ignore it next time. Well, that gets into the category of low probability, high impact, okay? Where you may not think the chance of it being catastrophic is very high, but if you haven't done everything in your power to protect yourself in case it is, then you are going to suffer the consequences from that. This is what I always told people during tornado warnings. The chance of it going right over your house is small, but go to your basement or your safe place for 20 minutes, and if nothing happens, don't be mad, be thankful, okay? We wish we were good enough to get it right down to your house, but we're not. Science is not there yet. So while Hurricane Helene devastated the mountains of North Carolina, the effects near the landfall location were not all that terribly bad, or at least not nearly as bad as had been anticipated. So the question is, why? Frictional effects, as I mentioned earlier, will always lessen the wind speed somewhat near the ground, but not to this extent. The instrumentation at the Perry, Florida airport never measured sustained winds or gusts close to what the radar showed aloft. While Hurricane Helene devastated the mountains of North Carolina, the effects near the landfall location were not all that bad. The sea level pressure at the Perry Airport dropped to 948.5 millibars, or 28.01 inches of mercury. The highest sustained wind was 55 miles per hour. Okay, that's 80 miles an hour less than the sustained winds the radar was measuring 3,500 feet above the ground. And the highest gust was 99. Okay, now another thing that is worth noting here is that when you hear the Hurricane Center or read the advisory and you hear maximum sustained winds or such and such, that doesn't mean that the maximum sustained winds are occurring all the way around the eye wall. It's in very, very select locations within that circulation. And the chance of that location going right over an observing station is very, very small. So almost by definition, the observed winds at landfall are never going to be as high as the maximum sustained winds that are reported in the advisory. So that issue and the effect of friction, again, is going to bring it down a little bit. I just don't know that I can use that to justify an 80-mile-an-hour difference. So some final thoughts here. Is there a chance that there was some shallow, cooler water right near the coast that cooled the air above it, and then that air was advected inland by the wind and made the atmosphere a little bit more stable? In other words, if it was cooler near the ground and it actually warmed up as you went up through the atmosphere, that would make it difficult for the strong winds up there to mix down to the surface, okay? And so that's one possibility, okay? The other thing is that there might have been a thermodynamic effect, and again, preventing the mixing of higher wind speeds to the ground. And that could be more than just what I just mentioned about the shallow, cool water. There could be some other things going on there with regard to the temperature lapse rate that are not well understood at this point. And why is this suddenly an issue now, where in the past the highest wind speeds seem to be pretty much in line with what was expected, okay? Take Hurricane Camille in 1969, one of the few Cat 5s to ever make landfall along the U.S. coast. And, there's a famous story about a whole bunch of folks that had a hurricane party, and none of them survived because the winds were that bad and the storm surge was that bad. So, this seems to be a relatively new phenomenon. And I did correspond today with my friend Kerry Emanuel, a retired professor of meteorology up at MIT, and also Gary Lackman, professor of meteorology at North Carolina State University. And Kerry was very honest with me. He said he was just at a meeting about safety regarding hurricanes, and when they asked him why the winds were so much less than expected, he had to be honest with them and tell them that he honestly didn't know. Kerry Emanuel is a member of the National Academy of Sciences. You don't get into that unless you're brilliant, okay? And for him to have the courage to say, I honestly don't understand why this is the case, tells you a lot about him. He is brilliant, but he's also humble and he's also honest. And that's one of the things I admire about him. Gary Lackman told me that he has a graduate student, a very good graduate student, who is working on this very issue. And he said the effects, the thermodynamic effects, may be even greater than the effects of friction. And so I'm going to be keeping in touch with Gary to see what that graduate student finds as he continues to do the research. And, the meteorology department at NC State is, one of the highest respected departments in that field anywhere in the country. And so they're doing some great work over there. And if you're young and you're thinking about going into meteorology and you live in North Carolina, I guarantee you can't go wrong going to NC State for that particular field. And the other thing is you'll make your parents happy because it's in-state tuition. I had the same thing go on with me at Penn State, is that I live 2.5 hours from one of the best schools in the country for meteorology, and so it made the price tag quite a bit less than it would have been had I lived in a state other than Pennsylvania. So anyways, some interesting things here. research ongoing. There's always things to learn. That's what makes any type of science so great and so fascinating, is that you never know everything, nor will you ever know everything, and there's always opportunities to learn. Okay, folks, that's it for now. That's bonus weather video number 3 for this week. Number 1 for next week will be on Monday, and the next daily update, of course, coming up on Monday as well. So have a great Friday evening, and even better weekend. Enjoy the nice weather, and we'll talk to you again on Monday.